So this video is looking at the factor theorem and factorizing polynomials. So a special case of the remainder theorem is known as the factor theorem, and it states that if f of a equals 0, then x minus a is a factor of f of x. And conversely, if x minus a is a factor of f of x, then f of a equals 0. So in this example, we want to show that x plus 5 is a factor of 2x cubed plus 5x squared minus 28x minus 15, and then factorize fully. So our factor theorem states that for a factor of x minus a, f of a is going to equal 0. So that means that we want to find f of negative 5, and it should equal 0 if x plus 5 is a factor. So our polynomial is in descending powers of x, so therefore we can set up our nested form with 2, 5, negative 28 and negative 15. And our divisor is going to be negative 5. So now we're going to apply our synthetic division. So we're going to bring down the 2, we're going to multiply that by negative 5 to give us negative 10, we're going to add that on to the 5 to give us negative 5, negative 5 times negative 5 is 25, added on to the negative 28 gives us negative 3, and negative 3 times negative 5 gives us positive 15, and when we add them together we get 0, which demonstrates that we have a factor in x plus 5. Now, it says show that x plus 5 is a factor, so we need to explicitly state that because f of negative 5 equals 0, therefore x plus 5 is a factor. And we need to explicitly state this. Otherwise, we would lose 1 mark in an exam question. Now, it asks us to factorize fully, so we need to rewrite our polynomial as 2x cubed plus 5x squared minus 28x minus 15 equals our factor, which was x plus 5, our quotient, which is 2x squared minus 5x minus 3, and we don't have a remainder because this is being factorized fully. And we need to factorize that second bracket. So we've got x plus 5 upon 2x plus 1 x minus 3. So in our next example, we want to fully factorize f of p equals 3p cubed minus 7p squared plus 4. Now, first of all, we have a missing power, our p to the power of 1, so we need to rewrite this in descending powers of p, including them all. So f of p is going to equal 3p cubed minus 7p squared plus 0p plus 4. Now we've also not been given a start point for a factor, so we need to consider factors of the constant term. So factors of 4 could be plus or minus 1, plus or minus 4, or plus or minus 2. So we're going to set up our nest so that we can do our synthetic division, and our coefficients are 3, negative 7, 0, and 4. And we want our remainder to be 0 in order to be able to fully factorize this expression. So we can choose any of our factors of 4. So let's choose p minus 2 as a factor, giving us a divisor of 2. So bring down the 3, multiply it by 2 gives us 6. If we add that, we get negative 1. Multiply that by 2, negative 2. Add that to 0 gives us negative 2. Multiply that by 2 gives us negative 4. If we add that, we get our remainder of 0. So let's rewrite that as 3p cubed minus 7p squared plus 4. And that's going to equal our p minus 2 factor and our 3p squared minus p minus 2 quotient. And we can then factorize fully, which means that we need to factorize that second bracket of our quotient. And so we're going to get p minus 2 upon 3p plus 2 and p minus 1, which is our function fully factorized. Now in our final example, we want to fully factorize 2x cubed plus 5x squared minus 28x minus 15, given that 2x plus 1 is a factor. Now our factor is in the format of ax minus b. So we want to find f of b over a, and that's going to equal 0 if 2x plus 1 is a factor. So our f of b over a is going to be f of negative a half, which should be 0 if 2x plus 1 is indeed a factor. So let's set up our nested form in order to do our synthetic division. So our coefficients are 2, 5, negative 28 and negative 15. And we're going to put our remainder of 0 and our divisor of negative a half. So we bring down the 2, multiply it by negative a half gives us negative 1, add it on to 5 gives us 4, multiply that by negative a half gives us negative 2. If we add them together we get negative 30, multiply that by negative a half we get 15, which gives us our remainder of 0. So we're going to rewrite our function in terms of the factor and its quotient. So 2x cubed plus 5x squared minus 28x minus 15 is going to equal x plus a half upon 2x squared plus 4x minus 30. Now we need to factorize that second bracket. There's a common 2 in all three terms. So we're going to get x plus a half, and our common factor of 2 multiplied by x squared plus 2x minus 15. We're then going to combine that 2 with the first bracket to get the 2x plus 1 factor in the initial question. So 2 multiplied by x gives us our 2x, and 2 times a half gives us our plus 1. And then we're going to have x squared plus 2x minus 15. Now it says factorize fully, so we need to factorize that second bracket. So we're looking at factors of negative 15 that are going to give us a positive 2. So our options are 15 and negative 1, that doesn't work, and 5 and negative 3, which gives us our positive 2. So that is the factor pair that we want to use for factorising that second bracket. And so it equals 2x plus 1 upon x plus 5 upon x minus 3, our fully factorised solution.